Good morning, everybody. Last time we have to introduce the gases law. In gases law, Boyle's law, we have to explain. Today, I will explain Charles law as well as Gay-Lussac law. So, Charles law states that for fixed mass of a gas at constant pressure, volume is directly proportional to the absolute temperature. In case of Boyle's law states that for a fixed mass of a gas at constant temperature, pressure is inversely proportional to the volume. And here in Charles law states that for fixed mass of a gas at constant pressure, volume is directly proportional, keeping your mind, directly proportional to the absolute temperature. Here, V proportional to T at constant P, because here is P is constant, V is volume, T is temperature, that is absolute temperature, and P is pressure. So V proportional to T in case of Charles law. When fixed mass of a gas in a container at constant pressure, at that time at constant pressure, volume is directly proportional to the absolute temperature, and therefore V equal to Kt. V equal to Kt or V upon Kt equal to K. V equal to Kt or V upon T equal to K. This is the mathematical equation of Charles law. Again I repeat this. Charles law states that fixed mass of a gas at constant pressure, volume is directly proportional to the absolute temperature. So this is the proportionality equation, V proportional to T at constant P, or V equal to Kt, or V upon T equal to K. Here K be the constant, V be the volume, and T be the absolute temperature. In case of Charles law states that the ratio of old volume and old temperature is equal to the ratio of new volume and new temperature is constant. Ratio of old volume and old temperature is equal to the ratio of new volume and new temperature is constant. Another way I can say that the ratio of initial temperature and the ratio of initial volume and initial temperature is equal to the ratio of final volume and final temperature remain constant or is constant. That is V1 upon T1 equal to V2 upon T2. Again, I repeat this Charles law. Charles law states that for fixed mass of a gas at constant pressure, volume is directly proportional to the absolute temperature. In this case, proportionality equation V proportional to T at constant P, and mathematical equation V equal to Kt or V upon T equal to K. When both volume and temperature remain constant, so the ratio of old volume and old temperature is equal to the ratio of new volume and new temperature remain constant. So there is V1 upon T1 equal to V2 upon T2. So V1 is the initial volume or old volume, T1 is the initial temperature or old temperature, V2 is the final volume or new volume, and T2 is final temperature or new temperature. So this is our Charles law. Again I repeat the definition or statement of Charles law. For example, we will take container, and in the container there is fixed mass of a gas. The mass of gas or weight of gas is fixed. At that time, pressure remains constant, and volume V is directly proportional to absolute temperature. And this is the graphical diagram of the Charles law. The graph is plotted between temperature and volume. Temperature along x-axis and volume along y-axis. Here is graph is plotted in a straight line. So here is this is the pressure and pressure is directly proportional to the volume, or volume is directly proportional to the absolute temperature at constant volume. So this is the constant volume, this is the constant pressure, keep in your mind. Our graph is plotted between temperature and volume. Temperature along x-axis and volume along y-axis, and pressure remains constant. So this is the constant pressure, goes on increasing. Then Gay-Lussac law. Gay-Lussac law states that for a fixed mass of a gas at constant volume, pressure is directly proportional to the absolute temperature. Keep in your mind, in Charles law, volume is directly proportional to the absolute temperature, and in case of Gay-Lussac law, pressure is directly proportional to the absolute temperature. So same position in all these law: Boyle's law, Charles law, and Gay-Lussac law. In each law, fixed mass of a gas, this is the proper statement for all gases law. So fixed mass of a gas, constant volume, pressure is directly proportional to the absolute temperature, and here is P proportional to T at constant P, because our statement Gay-Lussac law states that P proportional to T, or pressure is directly proportional to the absolute temperature at constant volume. So P equal to KT. So P equal to KT, here is P is the pressure and K is the constant and T is the absolute temperature. So our statement Gay-Lussac law states that for fixed mass of a gas at constant volume, pressure is directly proportional to the absolute temperature, and therefore we can write the equation, proportionality equation, P proportional to T at constant V. P equal to Kt, or P upon T equal to K. P upon T equal to K, or P upon T equal to constant. So K is constant. Here P1 upon T1 equal to P2 upon T2. Here P1 is the initial pressure, P2 is the final pressure, T1 is the initial temperature, and T2 is the final temperature. Another way, the ratio of initial pressure and initial temperature is equal to the ratio of final pressure and final temperature remain constant, or the ratio of old pressure and old temperature is equal to the ratio of new pressure and new temperature remain constant or constant. So this is the statement of Gay-Lussac law. So what is our statement for Gay-Lussac law? Gay-Lussac law states that for fixed mass of a gas at constant volume, pressure is directly proportional to the absolute temperature, and therefore we can write the proportionality equation P proportional to T at constant V. P equal to Kt and P upon T equal to constant. So P equal to Kt and P upon T equal to constant. This is the mathematical equation of Gay-Lussac law. Another way, the ratio of initial pressure and initial temperature is equal to the ratio of final pressure and final temperature remain constant. So in case of Gay-Lussac law, or in our proportionality equation and mathematical equation, P is the pressure of the gas, T is the temperature of the gas, and V is the volume of the gas, and K be the constant, gas constant. Then P1 is the initial pressure or old pressure, T1 is the initial temperature or old temperature, P2 is the final pressure or new pressure, and T2 is the final temperature or new temperature. So this is our gases law. So again I repeat our Boyle's law. Boyle's law states that fixed mass of a gas at constant temperature, again I repeat this, fixed mass of a gas at constant temperature or absolute temperature, pressure is inversely proportional to the volume. Inversely proportional in case of Boyle's law. Then in Charles' law states that for fixed mass of a gas at constant pressure, volume is directly proportional to the absolute temperature. Volume is directly proportional to the absolute temperature. In case of Gay-Lussac law states that for fixed mass of a gas at constant volume, so here is at constant volume, pressure is directly proportional to the absolute temperature. In case of Boyle's law, at constant temperature, absolute temperature, so at constant absolute temperature, pressure is inversely proportional to the volume. At constant temperature, pressure is inversely proportional to the volume. In case of Charles' law, at constant pressure, so you get volume and absolute temperature. So volume is directly proportional to the absolute temperature. In case of Gay-Lussac law, at constant volume, pressure is directly proportional to the absolute temperature. So in gases law, pressure, volume and temperature or absolute temperature. This is three important parameters, and our statement, our definition depends on these three parameters: volume, pressure and temperature. If volume constant, pressure is directly proportional to the absolute temperature. This is called Gay-Lussac law. If pressure constant, volume is directly proportional to the absolute temperature. This is our Charles law. And when temperature remain constant, pressure is inversely proportional to the volume. Keeping your mind, pressure, temperature and volume. And this is the graphical diagram of Gay-Lussac law. This diagram we have plotted in between temperature and pressure, because pressure is directly proportional to temperature at constant volume. This volume. Keeping your diagram, keeping your mind, this diagram, here is dotted line, here is the temperature is negative, the volume increases. But in case of first quadrant and also second quadrant. So this graphical diagram shows the Gay-Lussac law, and this is the ideal gas equation. So ideal gas equation, pressure and volume, this diagram or this graph plotted between volume and pressure. This graph plotted among the volume and temperature. This graph plotted among the temperature and pressure, and this graph plotted among the volume and pressure at constant temperature. So my friends, this is three laws is very important for your view of examination. Generally numerical problem may be asked in your examination, that is 2 to 4 marks. So keeping your mind this old statement. So now I stop here. Thank you very much.